Hi, welcome back. Wanted to dive right into a quick example here. This is a response to a question that came into the forum a few weeks ago. I think it's actually longer than that now, maybe a month ago. Scott was asking about some, an example of SpriteCollision. Now, there's a lot of SpriteCollision examples on the forum if you care to look through them. There's a bunch in the help files as well. It's kind of a big topic, actually. There's different types of SpriteCollision that you might want to try and use. Most of the variations that are built into the Sprite commands. Where are we? So this is the creation section, the drawing, list, vertex, draw modes. Down the bottom here somewhere, there we are. So we've got all these commands here that deal with collision. As you can see, there's a bunch of them. A lot. Probably too many, to be perfectly honest. We've got some commands that are doing very specific things. We're comparing to see. Here we've got a command that checks if Sprite is hitting ellipse. So you could use this kind of command to do as a trigger. For example, you could have like a mathematical region within your game world, and you could go, well, I'll compare this region to the Sprite. If they overlap, then we could have some action that's created because of that. Maybe the player walks into a spawn point where all the bad guys get spawned, and that's how the action takes place. This one here is doing pixel perfect. Some of these ones have pixel perfect modes and other ones don't. If it has pixels in the end of the command, it's a pixel only command actually. The returns here are very simple. If there's no overlap, it's 0. If there is an overlap, then it's 1. But you can't actually get where the intersection has occurred. It just checks to see if there's any part of these two things overlap. If they do, that's a collision. And that's actually the way the whole library works. It's just checking to see if two of these rectangles or shapes overlap. If they do, bang, they've hit each other. There's a few exceptions, I guess, with the sprite hit world and those kind of things. There's some sliding collision stuff tucked away in there. But it's kind of old now, probably outdated to be perfectly honest. Nonetheless, let's go back and look at our example. Now, on the forum, this is Scott's example. He's doing a Space Invader clone, as you can see. I'll just make that a bit bigger for you. So it looks pretty good so far. Yeah, looks fine to me. Not quite sure what the SpriteCollision problems are, but hey, hell, let's have a look. I'm not looking at his code, by the way. This is the example I posted in response. So he's got a question. Can you explain pixel perfect collision detection with code snippet 2, please? So I said, yeah. Here's one example straight on the top of the forum. It does this, has a video, etc., has the code there, go for your life, go have a look at it. That one there is doing the collision detection manually. You compare pixel by pixel. In PB, you shouldn't really do that. Just use the Sprite stuff that's built in. As we're about to look at, so this is my response, and the example code's posted down there. So we'll switch back to PlayBASIC. Bingo, there we are. The example is probably, what do we got? We've got our load media. We've got we're randomizing a scene of simple sprites. And our main loop is doing a comparison of a sprite positioned at the mouse's coordinates with any of the sprites in the scene. If we detect an impact, we just return the sprite index that was hit. Let's run this thing. Pretty simple. Actually, we'll have to run that again because our sprite, they're sitting on top of the output. So up here we've got the output. Let's check if it hits that thing there. Oh yes. We've got a bigger version of itself. We're hitting this. Oh yes, we hit. Right. Now in the scene, my character here that I'm moving down the bottom is just in its normal size. The other guys, that they're scaled up. Now, so we're using a draw mode as well as SpriteCollision. Now, if we apply scaling or rotation to a sprite, we have to set its draw mode to rotate or scale mode, which is the mode 2. And that has an impact on collision as well. Although some collision methods don't actually care about the image at all. Like there's a rectangle mode, a circle vector mode, a shape mode, which is for using PlayBASIC shapes. Let's dig through the code and have a look at the important parts. So I hope you can follow this code. We are loading a sprite sheet into an array. It's a function I've written in the code down the bottom. Let's have a look at it. The only thing we're doing that's kind of dodgy really here is I've pre-sized the sprites. So I'm assuming that the sprites in the sprite sheet are 32 pixels in size. To make this more generic, you would have like a size up here somewhere, perhaps, you know. But you know, for a demo, who cares? Sorry, but who cares? So we're checking if this sprite sheet exists. If it does, we load it as an effects image, which is what the 2 at the end there checks. You might see a command like load new effects image. This is the same thing. You might think, well, why have 2 versions of it? Well, going back, way back in the day, people didn't like optional parameters. In fact, it was one of the things that people didn't want at all. They didn't want any optional parameters for anything. That's why we have different command names. Yeah. Myself, I don't really care, to be honest. Anyway, so we load our image, and hopefully it loads off disk. And we check if it does exist after it's been loaded, just in case something happened between when we checked that was it on disk and then we went to load it. It's possible that something could delete the file or move the file between there, even though that's very unlikely. I'd say it's probably a 1,000,000 to 1 chance, but hey, yeah, you know, maybe someone's playing your game off either burn it to a CD or something like that, or a USB device, or who knows, whatever. And you know how dodgy those connections can be sometimes. Yeah, you know. Nonetheless, we loaded the thing. We're gonna run through all the pixels in that image and clear out the alpha channel and keep the RGB channels. Now, this particular image has the alpha channel set to FF all the way through it. PB kind of prefers a 0 alpha channel with color 0. It actually has internal screening routines that prefer that color. It's cheaper for a comparison. So that if you use that as a side effect, you can actually make things run quicker. Not a lot quicker, mind you, but a little bit quicker. A little bit. Here we masked off the alpha channel. We're asking it how wide are you, dividing by 32, getting our number of frames, redirecting rendering to this image we just loaded, running through and grabbing these blocks pretty much 32 pixels wide as individual sprites or images. Sticking them all in this array, coming back to where we were. At the top here I noticed it's got a little loop there to draw them out. So if we put it in sync and wait key, what we should see is them drawn to the screen. And we do. So we know they're loading, it's all good. Chop that out there, who cares? So this is the sprite scene setup. The only thing interesting about this demo at all is the loading function for the image. For the images, I should say, this loading function here that we're just going to quickly looked at. And our sprite initialization function, which is this one here. So we're creating 11 sprites. We're looping through 11 times, creating 11 sprites. we're setting the sprite up, or we're randomly choosing our image from this sprite, our frames list that we just created before and stuck in the array. Wow, that's confusing, isn't it? Lots of crappy terminology coming at you all at once. I'm sorry about that. It's a very bad description of what's going on, but we'll press on. Let's try and get through this damn thing. So here we're making a choice. We're picking one of the frames that was loaded in and cut up and placed in this sprite frames array for us. We're choosing one of those out of the possible number of frames. It's an ugly looking statement, but that's what it's doing. Once we have that particular image, we then call our create invader sprite function, which we'll look at in a second. We're passing in a random position on the screen and this nice image that we just grabbed here. Now we could actually have here, if get image status this image, just to make sure that thing exists. And we shouldn't need it. Right, we're not changing the behavior. We're not actually doing anything to the function now that's all that crazy, but at least we're going, just make sure this thing exists before we continue on. What if this image up here didn't load properly? For example, this function won't error out. It'll just, if the file doesn't exist, it'll just skip this whole thing and return. We come down to the bottom, we come back to the start here, and we're going, okay, let's draw a bunch of frames that don't exist. In this case here, it'll skip over those because that'll be 0. And here, we can't choose a frame because there's frames that don't exist. We probably would end up with a circumstance where we're trying to use an image with a sprite that doesn't exist and get a runtime error. Another long-winded, convoluted explanation, but hey, it's that time of day, man. Let's look at the important part. This is the function that sets up each one of the sprites on screen. We're calling the same function. It sets up whether the sprite is on screen, its position, its image, what draw mode it has, and its collision type, which is all we care about in this demo. Fine declaration for us. Here's our create invader sprite function. Notice the same kind of protection here. We're actually checking the sprite exists as it passes through, just to make sure we're not passing something that doesn't exist. Being a bit overly careful, even though it is a demo. We're trying to give people an idea of, you should do some sanity checking in your code to make sure stuff is doing what you think it's doing. First thing we do, we check if this image we just passed in, does the thing exist? If it does, okay, cool. Let's create a sprite. We'll create the sprite, give it the position we just passed in as well, and this sprite image. Now, when a sprite is created, they actually have a whole bunch of properties. I can't think of off the top of my head, but there's probably let's say there's 50 different individual settings for the sprites have by default. Some of those if you look under the certain commands that in the sprite command section, as we were doing before, down here into sprites, sub alpha, you'll often see bits and pieces where it will tell you what the default is. Didn't in that case. Sometimes it does. Now Sprite's default draw mode is actually 0 or 1, I think it is internally, which is blip mode. Now blip mode takes the image that you're using with that sprite and draws that image exactly as it is. No transformation, so you can't scale the image, you can't rotate it, you can't modify the pixels, nothing. It just gets splodged onto the screen at the sprite's current coordinates. So it's great for old school sort of 2D games where you not really modifying the images that much. In something like a Space Invaders, that's kind of a nice way of going about it. Here we're setting it to mode 2. Now mode 2 is rotation mode. We need that because we want the sprite to be scalable, and we want to be able to turn the sprite as well. We could probably add that to this example here if you wanted to. But we'll leave it for this time being. Other modes here, this is for drawing variable alpha blending of the sprite onto the screen, which is translucency, pretty much. And that's, you supply the amount of translucency and it will blend your sprite with the background at whatever that level is. There's a special mode for 50-50 blending. There's an addition mode, a subtraction mode. There are 2 subtraction modes actually. You can take the sprite, be subtracting from the background, or you can subtract the background from the sprite, because they give different answers. Just makes a weird kind of effect, you know. There's a fade there, which is kind of similar to doing a blend, but we're modifying the pixels as they're picked from your image, and then doing a modification of them there, and then writing them out to the destination. So we don't need to read the destination, which is important for performance reasons. Things like blending and subtraction, they have to read the destination. So it's best to work with effect surfaces for those things. Whereas things like blip mode actually works best for video mode stuff. That's the traditional GPU sort of accelerated stuff, but they can't do, it just does direct copying, because PB is based around direct draw and a very old version of direct draw for backward compatibility reasons. Yeah, it was, I mean, seriously, it was designed, 2002? So, it will get changed, it will get updated, but we won't be able to call it the same thing because it won't be backward compatible. We try to make libraries that are backward compatible and they just don't work very well. There's so many little gotchas that pop up and stuff. Anyway, so this is all about the draw mode stuff here. If you're wondering about how to do things with sprites real time, then that's where you need to go. Look up Sprite Draw Mode, which is how I'm scaling the alien sprites. Let's have another quick run here. See how these guys are blown up, nice and chunky. And I'm nice and small down here. Ooh, cool. That's what's doing it. What we wanted though is all about the collision. So this command here is setting our sprite handle. This is the center. This is how we do our centering. We can just tell it to center the sprite handle for whatever this image is in size. This means that when the sprite is drawn, it computes its current image, the width and height of that, and then normally when we're rendering a sprite, we're manipulating, or we're attached to the sprite's upper left-hand corner. When we do it this way, when we center the sprite handle, we're handling the sprite in the middle of the sprite, which is very convenient for display purposes. We don't have to worry too much about the size of the sprite. I guess you still do, but you know. You don't have to position the sprite. You don't have to center the sprite all the time yourself. That's the main point I'm trying to get to with that. That's all the center thing here does. If we disable that, you won't really see much difference, except I think my ship will be handled on the corner. Now if you look closely, I'm no longer handling my little ship in the middle, I'm at the top left hand corner. Let's restore that. This is the only part that matters. So we've prepared our images in an appropriate format. They're in an effects format. We've cleaned off the alpha channel from them. So when we want to do pixel mode collisions, we turn sprite collisions on, which I think it defaults to being off. There are some other things that we can do here to have them grouped differently. We can have things called the collision class, but we won't look at that at the moment. And the important one here is we set the SpriteCollision mode to 6. There are actually, there's 7 modes really. So mode 0 is the default, that static rectangle. So just like we have a render mode that does a direct copy of our image with no stretching, no effects, no nothing. It just copies those pixels as they are in that sequence. This static rectangle does exactly the same thing. It just keeps, it just checks the bounding box of this shape. It doesn't matter what the contents of the image are at all. It's just checking for a mathematical detection of if something overlaps this rectangle. So the pixels aren't even considered in this mode. Rotate rectangle is the same. We're not looking at pixels there at all. We're just looking at if we're using rotation modes, then this will rotate. It'll compare the rotated scaled rectangle around the sprite, but not the pixels internally. Circles for one's situations where you have shapes, or your images are circular, and you want to just have a circle mode. You can just set the radius, and off you go. There's a much more complicated method here for shapes, which is you draw a vector shape around the frames. With our method for shapes, you can actually have convex, concave, and complex shapes. To be blunt, you want to use the most simple shapes possible. It's just an outline around the thing you want to collide with. The best benefit of that is you can actually make your shape a few pixels inside the graphics, so you can have a bit of leeway with your collisions. The worst thing about using the actual image for collision and display is that if you have any shadows attached to your image or any sort of feathering off on parts around your frames, that'll be detected and probably give positive results for collisions, and it might drive players nuts because you can't have two characters getting too close to each other because the frames, a few frames of animation might actually have some weird dots here or there that might drive people mental. Anyone who's played, old school 90s games, 90s or 80s kind of 16-bit games or 8-bit games, probably knows what I'm talking about. Sometimes when the collision zones aren't that great, it makes a game that might look fantastic just ruins it. These are for world stuff. This is for kind of sliding collision stuff, which are to do with the circle mode there as well. And finally, pixel perfect. There's a bit of information on each one of these modes. If we go in the bottom, it's mode 4, mode 5, pixel perfect. So we've got another command there to help with the accuracy. So we can actually have pixel perfect collisions, but we can have them less accurate, which is good for if you have really big images. You can scale things down a bit and win some performance back that way. If you have really small images, you can make them bigger, which makes the collisions sometimes in an image that's been scaled, some pixels will be jumped over and they might miss in collision detection. Since we're actually just comparing what the two images look like when they're rendered. Imagine like a crosshash pattern or something like that, where you've got some pixels that are a certain, like green or something like that, and then some transparent pixels, and then some other ones. At certain scales, when you scale that down, you might have a point where whole sections of those green pixels are being skipped over and missed. Wow. Sorry, bombarding with lots of information all at once because, hey, it's 1:30 in the morning and almost Christmas. Well, 2 days away from Christmas. So pixel perfect mode is what we want to read, really. So here I'm saying when sprites are set to pixel perfect mode, the SpriteCollision engine can detect collisions between sprites on a per pixel basis, regardless of the sprite's rotation and scaling. The collision engine is also powerful enough to detect collisions between vector shapes and sprite pixels. So a sprite set to rotated collision mode 1, which is like a rotated rectangle, these can impact on sprites in pixel modes. So you can mix and match the different modes and get collisions between them. You probably never thought about it, but there's a bunch of code in the background to do this stuff. It's kind of pretty ugly. Let's skip on. It's important to understand that pixel level collisions always assume we're comparing two transparent sprite images or a solid vector region from another sprite to a transparent image. Obviously, if the sprite is solid, that would make every pixel hard, making it a rectangle. So what I'm saying there is if you've got an image where there's no transparent pixels in your image and you're using sprite mode, collision mode 6 for it, that's pointless. Just use rotated rectangle mode, because what you're doing is then you're setting up a situation where it can never fail. If the two things overlap, then there'll always be an overlap, but you're comparing the slowest method possible. Okay, since sprite collisions are on a per pixel level, this can be very resource intensive operation. As such, we've included a control to set the collision accuracy that you require. As a general rule, the higher the accuracy, the slower such calculations become. Because what you're doing really is you're scaling up the two sprites you're comparing internally, and the bigger they get, the more resource intensive this comparison becomes. The more work the routine has to work through. When they're actually compared, it doesn't compare the whole sprite. It just works out what region overlaps of the two rectangles, and then compares those overlapping spans with each other. It starts from top to bottom too, so it's not actually doing every second row first pass and every second row second pass or something like that, which in some situations could be better. Anyway, all right. So this is our sprite collision method. So that's our function. We've set our collision mode on, and then we're just back to normal. Here I'm using the same little sprite collision collision function, create all the sprites in the scene. So we're using the same function to set up and prepare our sprite in the way we want to use it within our program. Now this is a kind of concept that I wish more people would dive into, is that if we can modularize our own programs by making, if you go, well, hey, I don't want us to do this every time I write a program, well, I can make a little function, set it up in my own little include of functions I like to use, and then every time I write a new program, I just drag that code in, and I'm at the same position every time. It's like giving yourself a head start every time. For making things like games, I would definitely have this kind of structure. I would have some functions that create certain character types in my game. So I never do any of this stuff outside of this function. I would just call that function to create this character in my scene, and I know if something's wrong with it, that's where the problem's going to be. Let's go. Let's run the thing one last time. I think we've covered all the useful stuff. Although that now we can go inside. It's kind of cool. Ooh, cool. Sorry, being a bit of an idiot. We do have some things in PB that let you, for debugging purpose. Now, the command SpriteCollision debug, and we'll set this to on, and this will draw the rectangle around the sprite. Now we can kind of see that we are sharing space, so I'm up here. Now I move inside the rectangle, we're still not getting a collision until we actually cross over the pixels. Pretty cool. To be honest, there's probably going to be situations where you have the odd, false positive here or there. I'm not sure if the display code and the collision code are are exactly the same. I got a feeling that the collision code's a bit different, to be honest. But that's even older than the display stuff. What we could do, for one sort of final little example, if we let's have a little for next loop, for loop 1 to 1,000. Just call it SPR for Sprite. If get Sprite status, probably should be exist, to be honest, but same principle. So we check if this Sprite exists, and if it does, we'll go turn Sprite SPR, we'll go 0.05 or something. Turn them all very slowly. Now I can see it's showing us 2 rectangles around the sprite because debug mode's enabled. We've got the bounding volume of the sprite and the actual rectangle of the sprite of the graphic. Now I've got some, there's a bit of inaccuracy there as well. But, hey, you get that. But same thing, we can move my characters over here, I can move over into the same space, we're not colliding with it. Boom, hit it. Alright, that'll have to do us, I think, for today. Hope you found that rambling garbage of any way useful whatsoever. Let's just recap the important things. When you load your images in, if you want to do pixel perfect collisions, then make sure you load your frames in as an effects image. And if you want pixel perfect collisions, then I advise using mode 6. If you're having trouble finding out if something's overlapping, try enabling debug mode for the sprites that you're worried about. If you're using effects rendering, then set your sprites up to mode 2. Now, actually, I'll show you this. If I let sprite mode be the default, so it's not set to rotation or scale mode, what actually happens? Let's have a look. Probably thinking, what's going on? Well, because our draw mode is set to draw the graphic as it exists, so it doesn't do any transformations at all. It just copies the pixels as the actual size they are. So it's not responding to scaling or rotating at all. But our collision mode, it's responding to how the sprite is scaled and rotated. So that's something that you might need to be aware of if you're going to start playing with this stuff. Alright, we'll leave that there. Thanks a lot for watching, and hope you have fun for Christmas, and we'll see you next year. Bye.